Welcome to our first tool that we're going to be using for proofs, and that is called a directed proof. Now, before I get into problems and all that type of stuff, there's really two steps here. I want to make sure that you understand the concept of what we're doing and why we're doing it. Then I'll get into a little bit more about the overall setup, and then I'll get into problems. So this is going to be a multifaceted setup for this. So first of all, in the overall definition of what we're doing, is we're doing a direct proof of the claim or statement that P implies Q, and it takes that sort of form. Now, for a direct proof, we're going to assume P is true in our overall hypothesis. And I'm going to go over that here in a moment, what hypothesis means. And then we're going to complete an argument, which you can say you can use your P that's already true to show that Q is also true, and therefore your Q is your conclusion. So notice there's three steps of what we're going to be doing here. It's going to be our understand or assume our P in our hypothesis. Then we're going to do our argument, which frankly is the toughest part of the whole thing, to go from using our P that's true to show that Q is true. And that's using all those mathematical definitions that we talked about. It's going to be using some math. I know you haven't seen an example of it yet, but I'm trying to give you a heads up of what that's going to look like. And then frankly, the conclusion is the easy part. Hey, we found it, and then we're done. Now, speaking about that, in our conclusion, don't forget we're going to have that QED. I talked about that in the last video. But anyway, now how and why does this work? Remember your propositional truth tables here? So notice another item that's tying into what we've done before. So we're hoping that, Frank, it's going to match up with our first line that we have in our table. And that is, it's going to be true that P, we're assuming P is true. We're going to find, or hopefully find, that Q is also true. And that's going to mean that it implies that we have a true for that proof. So that's what we're hoping for when we do this type of proof. Now, let me eliminate the last two. Remember the last two were vacuously true? And that's because P never got off the ground, it was already false. So we're not going to use the last two. So that's why those two lines are basically crossed out, or rows, whatever you want to call it. We don't consider P because P is false. We're not looking for that. We want the truths to happen. We want both sides to be true. So let's eliminate that part. The one that's highlighted in orange is one that frankly we might have happen once in a while, but we're hoping not. And that's that we use P is going to be true, but we end up finding that Q is false. Then the whole thing is false, that in the implication. So again, we're assuming that P is true, but frankly, we hope it doesn't come to this, but there might be a time where like we just can't prove, or frankly, Q straight up is false. That means we can't prove that that theorem is true. So, or that claim, whatever we want to call it. So that's what we're doing when we're the overall concept of a directed proof.